When adding fractions and whole numbers, the thing to remember is that whenever you add with fractions, you always need a common denominator because you have to be counting the same thing. For example, if you look at the number 4, what is 4 counting? That 4 is counting wholes. So how do I express that as a number of thirds? Is I multiply by 3. 4 times 3 is 12. So the numerator becomes 12, and 4 is, in fact, equal to 12 divided by 3. So 4 is 12 thirds. Here's another one. How many fifths is 4? So same thing. 4 is counting wholes. So if I divide each whole into 5 parts, I'm going to need 20 of them to get 4. And 4 is equal to 20 divided by 5. All right, so let's look at that when there are already some other fractions. 4 plus 2 fifths. In order to combine these as a fraction, we need to use the denominator of 5. So I need to rewrite the 4 to be something over 5. 5 is my common denominator. So the second number is already 2 over 5. And 4, to write 4 over 5, you need to multiply by 5 over 5, which gives you 4 being 20 over 5. So I get my answer, 22 fifths. All right, here's the second answer. This one has fifths and thirds and the invisible wholes, because that's what 4 is counting, wholes. This 2 is counting thirds, this negative 17 is counting fifths. So common denominator is 15. So I need to write every number over 15. Okay, so this one, to get from 5 to 15, I need to multiply by 3. 17 times 3, I wish I had my little chart. I would just look it up. 3 times 1, 4, 5, 51. This one's going to be easier. To get from 3 to 15, I need to add a factor of 5, so I put the 5 up top. So 2 thirds is the same as 10 fifteenths, and 4 is the same as 60 over 15. So I end up with, now I have a common denominator, so I can add them. So let's add the 2 positive ones, combined to be 70 divided by 15, subtract 51 over 15, take their difference because they're different signs. So that is positive, because 70 is bigger than 51, 19 over 15. That is the answer. Okay, in Friday's class, we are going to be looking at combining numbers where one of the factors is unknown. For example, if I have 2 times x plus 3 times x, technically I cannot add these because I have to do this product before I can add. However, if I think of the 2 as counting how many x's I have, and this 3 as counting how many x's I have, then I can see that I have a total of 2 of them plus 3 of them to give me a total of 5 of these things called x. So it's kind of like adding up apples. If I have 2 apples plus 3 apples, I end up with 5 apples. All right, you can also do this with fractional quantities. 1/2 of an apple plus 3 apples is how many? Well, in order to combine these, I need to have a common denominator, which is going to be 2. So I need to write this number over 2, it already is, and this one over 2, which means that I have to replace the 3 with a 6. So 6 divided by 2 is in fact 3. So I end up with 7 over 2 x, 7 halves of x. Okay, let's do one more. X plus 2/7 of x. Okay, this one is a little bit harder because I cannot see how many x's I have here. And how many do I have? The answer is I have 1. So I do have a number there. I just didn't have to write it because 1 times x is x. So what's my common denominator is 7. So put this one over 7, put the other one over 7. That one, 2/7 is 2/7, but 1 is 7 divided by 7. So I end up with 9/7 x. Oh, crap.